lecture, we're going to be talking about implications. Now, implications are extremely important because all of discrete mathematics revolves around that concept. So please take the extra time to focus on what an implication is. Do not skip this lecture, because if you don't know what this is, then this entire course is going to be extremely difficult to understand. Hey everyone, real quick, I just want to mention that this video is a part of a whole course that I made. You can find a link to this entire course in the description below, and make sure to click on that subscribe button. So let's first start by talking about what an implication is. An implication or conditional is a molecular statement of the form P implies Q, where P and Q are statements. We say that P is the hypothesis or the antecedent. I'll sometimes refer to it as the premise. And then Q is the conclusion or the consequent, sometimes known as the consequence. An implication is true almost always, basically provided P is false or Q is true, or both, and false otherwise. In particular, the only way for P implies Q to be false is for P to be true and Q to be false. So easily the most common type of statement in mathematics is the implication. Even statements that do not at first look like they have this form conceal an implication at their heart. Consider the Pythagorean Theorem. Many college freshmen will cite the Pythagorean Theorem as something like a squared plus b squared equals c squared, right? Well, this is absolutely not correct. For one thing, that's not even a statement, since it has three unknowns in it. Perhaps they imply that this should be true for any values of the unknowns. So maybe like 1 squared plus 5 squared equals 3 squared? Well, no, that can't be right. How can we fix this? Well, the equation is true so long as A and B are the legs of a right triangle and C is the hypotenuse. In other words, I should say, if A and B are legs of a right triangle with hypotenuse C, then A squared plus B squared equals C squared. So this is a reasonable way to think about implications. Our claim is that the conclusion, the then part, is true, but on the assumption that the hypothesis, the if part, is true. Now here's the part that is absolutely crucial. We make no claim about the conclusion in situations when the hypothesis is false. Still, it is important to remember that an implication is connective in a statement, and therefore is either true or false. The truth value of the implication is determined by the truth values of its two parts, the if and the then parts. Technically, you can simplify the concept of an implication. We say that an implication is true either when the hypothesis is false or when the conclusion is true. This leaves only one way for an implication to be false, when the hypothesis is true and the conclusion is false. Let's go through an example together so that you have a better understanding of this. Consider a statement. If Bob gets a 90 on the final, then Bob will pass the class. This is definitely an implication. P is the truth value of the statement, Bob gets a 90 on the final, and Q is the truth value of the statement, Bob will pass the class. Suppose I made that statement to Bob. In what circumstances would it be fair to call me a liar? Well, what if Bob really did get a 90 on the final and he did pass the class? Well, then I haven't lied. My statement is true. However, if Bob did get a 90 on the final and did not pass the class, then I lied, making this statement false. The tricky case is this. What if Bob did not get a 90 on the final? Maybe he passes the class. Maybe he doesn't. Did I lie in either case? I don't think so. In fact, he might have gotten a 93, so he might have still passed the class. So, in these last two cases, P was false, and the statement P implies Q was true. So P is false, but P implies Q is still true. In the first case, Q was true, and so was P implies Q. So here's how this works. P implies Q is true when either P is false or Q is true. Now, just to be clear, although we sometimes read P implies Q as P implies Q, we are not insisting that there is some casual relationship between the statements P and Q. In particular, if you claim that P implies Q is false, you're not saying that P does not imply Q. So to say that this is false is not the same thing as P does not imply Q. You are saying that it is not true that P implies Q. Later on in this course, we'll show exactly why it is that P does not imply Q is not the same thing as P implies Q is false. So we'll show exactly why that is. Now let's go through some examples together. Decide which of the following statements are true and which are false, and briefly explain. Let's start with number 1. If 1 equals 1, then most horses have 4 legs. Well, this statement is true because the hypothesis is true and the conclusion is true. So the implication is definitely true. I can't prove it false. Number 2, if 0 equals 1, then 1 equals 1. That sounds false, but it's actually true. And the reason is because the assumption 0 equals 1 is false. And so false things can imply true things. That's okay. So just because something is false doesn't mean the implication is false. So just because the hypothesis is false doesn't mean the implication is false. In fact, as we saw earlier, if the hypothesis of an implication is false, then the implication is true. So number 2 is true as well. And let me label these so that you can have a reference. If 8 is a prime number, then the 7,624th digit of pi is an 8. Is that true or false? Well, that's true because, like number 2, that right there is false. 8 is not a prime number, and so I don't really even care about the conclusion. I don't even know if the 7,624th digit of pi is an 8. I have no idea. I don't do that for fun. But it doesn't matter because the hypothesis is false. And the way I think about this, I very frequently do this when I have political discussions. So if let me just make a real quick side tangent here. If you're ever in a political discussion with someone else, or some philosophical discussion or ideological discussion, oftentimes someone will bring up a hypothetical. Like, let's suppose, for example, that I'm a unicorn, right? And they'll come up with some crazy hypothetical that they just start with something that's false. And you immediately say, like, whoa, 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 whoa. First off, this hypothetical is useless. It's true, but it's useless. And so in the same way, if I start by saying, if 8 is a prime number, then everything that follows doesn't matter. The implication is true, and it's a completely worthless statement. It means nothing, and the implication shouldn't even really exist. So that's why it's true. And then lastly, if the 7,624th digit of pi is an 8, then 2 plus 2 equals 4. Again, the conclusion here is true, and the hypothesis here, well, I don't know. It could be true or false. But either way, if the conclusion is true, like it was in these two cases, it doesn't matter if the hypothesis is true or false. This will be true. The only way to prove that this is false is if you can show that the P here, the hypothesis is true, which maybe it is, who knows, and the conclusion is false, which it's not. 2 plus 2 equals 4. Good luck showing that's false. That's going to be really hard to show because it's not false. It's true. So for that reason, all 4 of these statements are true. Thanks, everyone, and I'll see you in the next lecture.